Okay, there are a few problems today in the class practice that are a little bit weird. As you have questions on them, I will sort of announce to the whole class what we would do in this situation. Okay, so there's going to be a few that we're going to come across. I also want to point out that, like, I start off here with number 112, but your book always, every single problem sort of comes in pairs. Okay, and so a good strategy, if you ever come to a problem where you're like, I don't know what to do. Well, if I gave you 112, then look to 111. So just back up. Number 11 and number 111 and 112 are, the same. And so what you can do is look at 111 and check the back of the book and see how they put their answers. And then you'll be like, oh, I get it. Okay. And you would do 112 the same way. All right, so we'll talk a little bit more about those. There's some interesting ones that pop up in here as well. Okay, so I'm hoping that you read example 5 and 6 on page 130. They were talking about slope and how we use slope. And then we're going to do a little word problem here. All right, so I am going to dictate. You know, it used to be in high school you would take a class on dictation. Many, many moons ago, you actually had a dictation course where you would sit there and you would learn how to take notes, essentially, how to write verbatim what people say, so you learn all these shorthand techniques for writing stuff. But I'm going to dictate, which just means I'm going to speak slowly enough that you can write down. Example 1. The sales for Best Buy. The sales for Best Buy were $35.9 billion in 2006. Worth $35.9 billion in 2006. And $40 billion in 2007. Write a linear equation. That gives the sales in billions in terms of the year. And then another really important part, let t equal 6 represent 2006. Okay. So I'm going to talk about a whole lot of things here in this one problem. And this is all I'm doing today. All right. So first of all, we are going to write a linear equation. You know how to do that. We did that yesterday. Yesterday, we used point-slope form. What is point-slope form? Y minus Y1 equals M times the quantity. X minus X1. Again, this is something you must have memorized. You must know how to use it. I will test you on it. So we are going to write a linear equation, which basically means if I know the slope and if I have an ordered pair, then I can write a linear equation. And these are what your word problems are about today. Okay, so if you have a point and a slope, you can write a linear equation. Or if you have 2 points, you can write a linear equation. It's 2 points, and I can find the slope and go from there. Now, let's talk about that linear equation a little bit more, because they're very specific. They say, we want a linear equation that gives the sales in terms of the year, where we're going to let t be our year. So I want an equation for sales. So that means we want an equation that says S equals, where S is sales. And then in terms of the year, in terms is actually a literal statement, meaning I'm going to have an equation, and somewhere in there, there's going to be a T in there, all right? It's a T apostrophe S, T's. So you're going to have like a t, or a negative 35t plus 42, or whatever it is, okay? So you're going to have an equation, and there's going to be t's in it in terms of t, all right? Now, anytime we do word problems like this, it's not a problem, it's an opportunity. So application exercises, okay? You'll notice I'm using variables s and t, which are not x's and y's. And this is often the hard part for a lot of students, is to figure out, well, I got to write an ordered pair. The order of those numbers matters, okay? And so when I read, I want an equation that gives sales, that equals the sales in terms of the year t. This is actually really, really helpful, because by the location of that information, I can figure out, how should my ordered pair look? What's the independent variable? T. Normally it's an x. Usually x's are over here, right? Okay. And we're equal to s, meaning s is the dependent variable. And it's really important that you get those in the right order. So now when I read stuff like the sales for Best Buy were $35.9 billion in 2006, that's an ordered pair. So what ordered pair would that be? So the year was 2006. I'm going to leave it 2006 for just a minute. And then $35.9 billion. 35.9, I'm going to write in the word billion. Billion. And then what's another order pair that we've got? 2007, and then 40 billion. So the order really matters. And again, it's 40 billion. I'm going to keep those units in there for just a minute. You might not think it's important, but it is absolutely essential, because if these aren't in the right order, when we calculate slope, we're calculating slope for something entirely different, okay? And so we want to make sure that our ordered pairs are going to give us what we want. The other thing we need to do is, you're going to have to pay a lot of attention to today, is this information. They're doing this a lot today, playing with time. And this is one of the coolest things about math, is that time didn't begin when Christ was born. Time begins whenever we say it does, okay? So here they're saying let t equals 6 represent 2006, which I always like to think that's kind of weird. I want to know, when was time 0? What year was it? 2000. Yeah, it's always good to think like that. You have a couple of problems where that'll come up, and if you actually know when we're starting time, then it makes it easier. Okay, which means I don't have to use big numbers like 2006. I can replace it with 6. And we're using 35.9. Again, a nice small number. I don't have to have 35, 9, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Oh God, too many zeros. We don't have to use those big giant numbers, because we're saying that we want the cells in billions. So this number, 35.9, represents $35.9 billion, okay? And we're not going to use 2007, we're going to use 7. All right, and again, 40, again, it's representing $40 billion. You, ladies and gentlemen, need to pay attention to units. I will get you on the next test on units. All right, pay attention. Now, I have 2 ordered pairs, and I want to write an equation. What do I need to do? Find the slope. Sure, my slope is going to be y2, so 40 minus 35.9. And I'm going to, slope has real meaning over 7 minus 6. I'm going to talk about that real meaning now. Your first couple of problems talk about slope, okay? What is the meaning of slope? Well, when we calculate a slope just on numbers, it's kind of meaningless. Okay, but when we're doing a real application here, the 40 and the 35.9 represented billions of dollars. And the 7 minus 6 really represents the year. All right, over 1 year. And so when we calculate the slope, what do we get? What's 40 minus 35.9? 4.1. Yeah. So, and it's not just 4.1, it has units on it, and that's really important. So when we think about this, this really means $4.1 billion per 1 year. So per year. An increase of $4.1 billion every single year. Let's just wrap our minds about that amount of money. $4.1 billion. Best Buy makes $4.1 billion each year more than the previous year. Okay? That's a lot of money. And then I think, yeah, they're getting me because, you know, I've bought like 4 TVs in the past 3 years. So, okay. I love TVs. Great. All right. So, we have a slope here, and it has meaning attached. And your first problem talks about that meaning. All right. So now I would plug it into point slope form, but again, I don't have x's and y's. What am I using? S's and t's. So what am I going to use instead of a y? S instead of y. So it's s minus s1 equals m times the quantity. I'm not using x's. What are we using? T for time. T minus time 1. Okay. So now I can plug in any ordered pair. I'm going to use the first one. 35.9 equals my slope of $4.1 billion per year. Oh my God. Times the quantity, time minus 6. And then you can go ahead and we can distribute. So 4.1 t minus, what is that, 24.6? Yeah, okay. It was really hard this morning, first period. It's a little better now. 35.9. So we have S equals 4.1 t. I don't know what that is. 11. Thank you. 0.3. Yeah, that looks good to me. All right. So again, this is our linear equation that gives the sales in terms of the year t, where t represents the years since 2000, technically. And you have to be very, very careful. Here's where you have to be really careful. The follow-up. Predict the sales for the year 2010. In the year 2010, what will t equal? 10. Why? Yeah, because time really started in 2000. Remember, it was 6 in 2006, which means it'd be 0 in the year 2000. Okay, and then 2010 would be 10 years after the fact. So I want to evaluate this formula when time is 10 to represent the year 2010. And I have to remember that these small numbers aren't small at all. I feel like Dr. Seuss. Okay. Because what does 11.3 represent? Is it $11.3? It's $11.3 billion. Okay, and that's where I'm going to get you, because I'm going to get you. Okay. That 41 plus 11.3. Yeah, and that would be 52.3. Okay. So after 10 years, or in the year 2010, well, what? They sold $52.30 worth of. Is it 52 bucks? No. Okay. So in 2010, the sales were 52.3 what? Billion. Okay. Really important, and I tell all of my students, if a problem begins with words, then it should end with words. Interpret what that means. Okay? And this is where I am going to get you on units. You've got to understand these numbers look small, but they're really talking about billions of dollars. All right? Do you have questions for me? All right, ladies and gentlemen, that's a wrap. And don't. Again, looking at your first problem, go back and read 111, sorry. Look in the back of the book, see what 111 does, and then you'll know how to do 112.
Oh, miss, it's the.
I'll be too.
Oh, got it.
Oh, I just want to let you know it's not recording. I'm so sorry.
Yeah, okay. Thank you.